In this lesson we are going to learn how to solve systems of equations. Okay. So far in algebra we have learned how to solve equations or polynomial equations which are in one variable. For example, 3x cubed minus 8 is equal to 0. That's a polynomial equation. Or we solved equations like 4x to the 5th power minus 6x cubed minus 7x is equal to 0. We solved several equations like these, we graphed them and all that. So all these are equations in one single variable. If you look, there's only x in there. Or maybe we could have an equation like y squared minus 4 equal to 0, but there's only one variable in here and that's y. In this equation, you only have one type of variable. So all of these equations, you can actually solve each equation at a time because it has only one variable in it. So here, if I gave you only 2x plus 3y is equal to 4, I won't be able to solve it because it has two different kinds of variable. One is x and one is y. So for two different kinds of variable, I need two different equations to solve. Another equation in x and y. So if I had an equation like x plus 3y plus 4z is equal to 8. If I had three different variables, I would need, that's the first equation, I would need another equation that has at least one of the variables in common, z equals to 3, and I need one more equation, x minus y equals 8. I don't need to have every single variable in it, but I need to have three equations where all of them share at least one of the variables. So 1, 2, 3. If I don't have three equations, I won't be able to solve this system. Okay, so for the number of variables must be equal to the number of equations that you need in order to solve a system. So I'm just going to quickly show you how the solution of this system right here is going to look like in the box. Okay, so we know that these are both linear equations. So when I graph the first equation 2x plus 3y equals 4, I'm supposed to get a line. When I graph x minus 3y equals 2, also I'm supposed to get a line. Because they're both actually linear equations of the form y equals mx plus b. Alright, they can both be rearranged, y can be solved, and both these equations can be written like that. So I'm going to pull up this graph that I already graphed of these two equations right here. So the one in red line is the graph of the equation in red, and the blue is the graph of the equation in blue. So if you look, you can see that they meet. Both the lines meet at the point 2, 0. That means the solution of these equations, or the system of equations, is 2, 0. That's what the graph means. Okay. So I'm going to write the solution over here. Solution of the system is given by, the solution is a point. You just saw that the two lines meet at a point x, y, and the x coordinate of the point where they meet, point of intersection, is 2, and the y coordinate of the point of intersection is 0. So that's what it means. Now the second case, systems does not always have to be between two linear. It can be, for example, it can be a linear and a quadratic. We know general equations for quadratic are, even though this ax squared plus bx plus c equal to 0, even though this is a general equation of a quadratic, the simplest quadratic is y equals x squared, and we know the graph is when it's like a U-shape, it's a parabola, right? So U-shape that goes up like that, right? It's not supposed to actually go down the line. I'm sorry about that. It's like that. So y equals x squared, that's the graph of a parabola, graph of a quadratic function. Y equals mx is a line. Okay, so let's say it's a line like that. Y equals mx plus b. So systems can be between a first degree equation or a linear and a quadratic. It does not always have to be between two linears. Okay, so does this have two solutions in here? See, do they meet? This quadratic and linear meets over here and meets over here. There are 2 points of intersections. So there are two solutions here. Okay, possibility is if the parabola, if you have a line, let me draw the line first. Let's say this is the line this is the line, let's say this is y is equal to 3. Okay, so this is 0, 1, 2, 3. That's the line y is equal to 3. Okay, so what happens if I draw a parabola like this? Let's say I have a parabola facing down and it's going through 1 and it's coming down like that. Okay, so this is my parabola. This is y equal to negative x squared plus 1. Negative x squared, so the parabola faces down, a plus 1, so from 0 it goes 1 block up. So what can you tell me about this linear equation and this parabola? If you really look at this figure, you can see that they're not intersecting at all. Alright, they're not, these two lines are not intersecting anywhere. So they don't have a solution. No solution. Is it possible to have a system where there is no solution? That it is possible. This is one case. There are thousands of cases like that. Y could be 4. It could be negative x squared plus 2. Or it could just be negative x squared. It could be below the y-axis. So many different ways where they won't have a solution. Just going back to the previous case, is it possible to have a no solution in this case when there are lines? That's also possible. If you have two lines which are parallel, like if their slopes are the same, if two lines are parallel, they will never intersect and they will never have a solution. So no solution is also possible in case 1. No solution is also possible in case 2. Now the third case is when a line intersects a circle. Now when we talk about systems, we have to remember the equations of these two types we are talking about. Linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. The general equation of a circle is like this. The circle's center is denoted by the letters h and k, just like a parabola's vertex. Okay, so a circle's equation is given like this: x minus h the whole square plus y minus k the whole square is equal to the radius of the circle square. Okay, so that's how the equation of a circle is given as x minus h square plus y minus k square is equal to r square. And the most general kind of circles that we usually work with is called the unit circle. Unit circle is when the radius is 1. So when the radius is equal to 1 and the center is 0, 0, that's the most general case. Okay, so since the center is 0, 0, h and k will be 0 and 0, and the radius is 1, 1 square will be equal to 1. So wait, let me write. Unit circle's center will be the origin, or 0, 0. So this is h, this is k, and this is r. When you plug it into the general equation, x minus 0 the whole square will just become x square, y minus k the whole square, k is 0, so that will become y square, and the radius is 1, so 1 square will just become 1. So this is the equation. X square plus y square equals 1 is the equation of a unit circle. Now, what are the different possibilities that can happen here? You can have a circle and you can have a line just touch it at one single point. You can have a circle, you can have a line intersect it at two different points. You can have a circle, you can have a line that will not touch it at all. So there are three different possibilities here. Okay. Now to give you guys an example of a circle intersecting a line and how to solve it, let me give you a question for this. Let's consider a unit circle. A unit circle means, we just discussed, the equation of a unit circle is x squared plus y squared is equal to 1. So consider a unit circle, and I'm giving you a line. My line is a little bit bent, I'm sorry. A line that's passing through the point -1, 0, and it's also passing through the point 0, 1/4, 0, 1/4 over there. Okay. You have to find the solution of the system. So they didn't give us any other information. The question is solve, and they gave you this diagram, and you have to solve this using systems. And all they told us is this is a unit circle. So how do we solve this? Since this is a unit circle, you can come up with the equation of the circle as x square plus y square is equal to 1. Now since this is a line, we have to find the equation of a line, and it has to be of the form y equals mx plus b. So first we find the slope. Okay, so to find the slope, what we have to do is we have to take difference in x over difference in y when 2 points are given, right? So if this is x1 y1, this is x2 y2, to find the slope I would go y2, which is 1 over 4, minus y1, which is 0, over x2, which is 0, minus x1, which is -1. So I have 1 over 4 over 0 minus 1 is 1. Any fraction divided by 1 or any number divided by 1 is just that. So the slope is 1/4. So after you find the slope, you have to use one of these points to plug in for y, and slope is 1/4. You will plug in for m, and you will plug in for x. Let's use this. This is the easy point. Let's use this for x and y. This is our x and this is our y. Let's plug in back into this equation to solve for b, to find b. So y is 0 is equal to the slope. We just figured it out as 1 over 4. X is -1 plus b. So that becomes a 0 is equal to -1 over 4 plus b. So to solve for b, I have to add 1/4 on both sides, 1/4. So they cancel, and I get b is 1 over 4. So I solve for m and I solve for b. So I have the equation of the line as y equals, instead of m I can plug in 1/4. So I have 1 over 4x plus, instead of b also I have 1/4. So now we got our two equations. So now we can solve this to find our answer. So I think we can use substitution to solve these two equations, okay? So the first equation, I'm going to write x square plus, instead of y, I'm going to plug in this expression right here. Since they both have the same denominator, I'm going to write it as x plus 1 over 4 the whole square is equal to 1. So instead of 1, I plugged in this whole fraction. Now I'm going to write it as x square plus x plus 1 the whole squared over 4 square is 16 is equal to 1. Now to get rid of the fraction, I'm multiplying throughout by 16. So 16x squared plus, I'm going to expand this using a plus b the whole squared. I get x squared plus 2x plus 1 is equal to 16, and 16 will cancel. And here also you multiply by 16, you get it like this. So combining like terms and rearranging, I get 17x squared plus 2x. Subtracting 16 on this side, I get minus 15 is equal to 0. By using quadratic equation, I get x, and two solutions for x are -1 and 15 over 17. So the -1 is already taken here. So I'm going to take, for the other point here, I'm going to take 15 over 17 as my x, plug it back in this equation here for x, and solve for y. You get your y as 8 over 17. An interesting fact here is that this 8, 15, and 17 form a Pythagorean triple also. An interesting fact from geometry.